Hello, and welcome to Climate Fix Podcast. Here we dive into evidence based solutions to climate change and various other pressing environmental issues. This is your host, Phil Ord.
This is your co host, DJ Leclerc. Warning: this podcast may challenge your views on environmentalism and push back on conventional environmental thought with science and data. We hope you approach with humanism and an open mind.
This podcast is created by Americans for Nuclear Energy, ANE, a pro nuclear environmental organization. We take no money from industry or special interest groups. All donations are from individuals like you, interested in a grassroots scientific movement to solve the world's most pressing scientific problem: global climate change.
Our mission statement is as follows: nuclear energy is safe, cheap, plentiful, clean, and efficient. It has the capability to stop and reverse climate change while addressing the ever growing demand for electricity globally. We strive to educate American citizens about this technology and to dispel misconceptions with facts. We firmly believe that both human civilization and industrialism can easily coexist with a healthy environment.
Join us in helping to plan a prescription for a feverish planet, or as we like to say, a climate fix.
We are pleased to talk to Dr. Patrick Brown to discuss climate science and the political divide on the situation. Patrick is a PhD climate scientist and an assistant professor in the Department of Meteorology and Climate Science at San Jose State University, where he teaches and conducts research on weather and climate and their interactions with society.
He holds a bachelor's degree from the University of Wisconsin-Madison in atmospheric and oceanic sciences, a master's degree from the department he is now a faculty member, meteorology and climate science at San Jose State University, and a PhD from Duke University in earth and ocean sciences.
He has also conducted research at the Carnegie Institution at Stanford University, NASA Jet Propulsion Laboratory at Caltech, NASA Langley in Virginia, NASA Goddard in Washington, D.C., and NOAA's Geophysical Fluid Dynamics Laboratory at Princeton University.
Dr. Brown has published peer-reviewed papers in Nature, PNAS, Nature Climate Change, as well as many other journals, and his research has been highlighted in the Washington Post, Newsweek, the Huffington Post, and the Guardian, among other places.
Man, this guy has an incredible list of accomplishments to his name. We struck gold here with such an expert willing to appear on our fledgling podcast.
You can say that again. I can't wait to have a conversation with him to really brainstorm meaningful action on climate and emissions reduction in this crazy political time. More than anything, we need level-headed experts to inform the body politic and finally solve problems instead of fighting. Anyway, stay tuned and we will be back with Dr. Patrick Brown. Dr. Patrick Brown, welcome to the podcast.
It's great to be here. Thanks for having me on.
So let's get into some of the basics. What is climate change or global warming? And is climate change real?
Well, so global warming generally refers, as the name suggests, to the observation that the globe, on average, has been warming up since the Industrial Revolution. And so it's about 1 degree Celsius warmer than it was prior to the Industrial Revolution. And we can kind of convert that locally to about 3 degrees Fahrenheit. So you can kind of think of it as like every single temperature that you're experiencing is about 3 degrees Fahrenheit warmer than it would be otherwise. So today the high in San Jose is going to be about 83. And so we can imagine that if we hadn't been burning fossil fuels, it would have been about 80 degrees as a high. And so then climate change is this other term that then kind of refers more to kind of the downstream impacts of that warming. So changes in precipitation, for example, or floods or droughts would be other parts of the climate that are changing basically in response to that change in global average temperature. And so we know that it's real from a lot more than just measuring it with thermometers, but that's our main way of measuring it. So we have a network of weather stations all over the surface of the planet that have gradually matured and become more comprehensive as time has gone on. But those date back to basically the 1800s, late 1800s. We have a record of global average temperature from thermometers. But we can also see this warming from measurements from weather balloons, from satellites that have been measuring this since 1979, from other observations in the Earth system, like changes in the cryosphere or ice. So, reductions in glacier length and volume, changes in the ice sheets, so reduction in the mass of the Greenland and Antarctic ice sheets, which are measured by satellites. We actually have these cool gravity satellites called GRACE that have this laser that bounces back and forth between two satellites. And when one satellite goes over, for example, the Greenland ice sheet, it's tugged by the gravity of the Greenland ice sheet, and it goes down a little bit, and that laser can sense that gravitational pull in the satellite. And so those have been up since 2002, and we can actually see that the gravity from the Greenland ice sheet and the Antarctic ice sheet is decreasing. So we're measuring mass loss that way.
Oh, wow.
And so we're measuring it in all sorts of different ways. And so there's a lot of evidence that the Earth is getting warmer, and it's basically it's unequivocal. There's no way that all of these things could be pointing in the same direction without a strong, persistent global warming.
Got it. I was just gonna say, you brought up kind of you differentiated between the terms climate change and global warming. I didn't really know the difference either. I kind of thought, global warming caused climate change, which you kind of alluded to. But when people are like, "Oh, the scientists are sneaky, they changed the name," are they wrong?
Yeah, I mean, there is kind of a drift in terminology. One of my pet peeves is when people say that, like, does climate change cause this? And that doesn't really make sense, because really it's what you're observing would be part of climate change. I mean, that itself would be climate change. So if it's like hurricanes are getting stronger, did climate change cause that? It's like, no, hurricanes getting stronger would be climate change. And so then a cause could be increasing greenhouse gas concentrations or something like that. Um, but yeah, I don't think there was any deliberate change of the name. I actually personally like global warming because that really is the main mechanism. Increasing greenhouse gases warms the globe on average, um, and even despite what you might hear about cold extremes, that's really not something that we're observing. Where it's there's this notion that, oh, everything gets crazier. It gets hotter and colder and whatever. But actually, when we look at the observations, it's the warming outweighs any type of mechanism that would cause uh, a cold extreme. And so it really is pretty global warming that we're seeing. And so I do like that. And then I like that as a descriptive term. And then, yeah, climate change would be additional things that might be changing within the climate, like precipitation, that wouldn't be part of the global warming term.
That makes sense. It's good to let everyone know all the terminology here. So, one last part of this question: uh, how do we know that climate change is not a Chinese hoax?
So I guess, do you mean the observation is getting warmer? Because we, have to rely on just all of this confluence of evidence. And so this is all, being assembled by competing groups around the world, and people want to come out with the best, most accurate data sets. And I kind of like that, as competition. It'd be very difficult. Any type of conspiracy really doesn't hold water in this case, because you have groups in all sorts of different countries with different interests coming together. And scientists are rivalrous too. Scientists love at academic conferences to say, "Oh, I don't, did you check this? Did you check this? Like, I don't believe your numbers on this." And that's kind of the world that we're living in. And so when you have everything pointed in the same direction, you're pretty sure that there's no conspiracy, Chinese or otherwise.
Got it. Cool. Okay. Well, moving on. Uh, are human are humans causing this current change, and how is this change different from previous massive climate changes on Earth? Because a lot of people say, "Oh, climate change is always happening." So, I was wondering if you could talk about that a little bit.
Yeah, it's a really good question. So it's certainly the case that the Earth has experienced a lot of climate changes in the past, and it kind of, you can kind of think of the climate as always changing at some rate or another. One thing that we have learned from looking at these previous climate changes is that the Earth the Earth's average temperature, this is basically a first law of thermodynamics problem where it just matters about what is the energy coming in and what is the energy leaving. And that's how you get a change in temperature. If you have a surplus of energy, then you're going to increase the temperature. And if you have a deficit of energy, you're going to decrease the temperature. And so if you think about the Earth, just floating around in space, there's only a few ways to change energy coming in or leaving. And so you can turn up energy coming in, which would be you can turn up the sun, or you can change, so turn up or turn down the sun, or you can change how much energy is leaving the Earth, which would basically come about from only two mechanisms. You can increase how much sunlight is reflected away or decrease how much sunlight is reflected away. Or you can change what we call the greenhouse effect, which is how easy it is for the Earth to emit radiation back to space. So basically, all climate changes can only come about from those three mechanisms. Either the output from the sun changes, or the Earth gets more or less reflective of solar radiation, or the Earth's greenhouse effect changes. And so when we can narrow it down to those three, that makes it a lot easier to attribute various changes to one cause or another. And so for the current climate change, we basically know that the sun is not getting brighter or dimmer, so we can eliminate that. And we have satellites looking at the sun and measuring the radiation, so we can eliminate that one. And then the other mechanisms that really go through the albedo channel, so that's how much energy is reflected to space. Those would be mostly volcanic eruptions, and we know that volcanic eruptions are not going in a direction that would cause the warming either. And so then that basically leaves a change in the greenhouse effect. And so we've known since the late 1800s that gases like CO2 and methane and nitrous oxide they selectively let in the radiation from the sun, and they selectively are opaque to radiation from the Earth. And so it's like putting on a jacket. They don't allow radiation to escape to space. And we know that we've been increasing the concentrations of these gases in the atmosphere. And we can even measure from satellites that right at the wavelengths that these gases absorb, that we can tell what wavelengths they absorb from looking at experiments just right here on Earth. And if you look up in a satellite, we can see those wavelengths not going back to space as much as they were previously. So we can measure the greenhouse effect directly from space as we're increasing these greenhouse gases in the atmosphere. And so basically, we know, okay, so I'll just go through the steps. It's like we have the fundamental physics that tells us that increasing greenhouse gases should cause the temperature to warm. We know that humans have been increasing those greenhouse gases in the atmosphere. We observe a temperature increase, which is exactly in line with what we would expect given those increases in greenhouse gases. There's other evidence, like the Earth is warming very uniformly, very globally. Like I mentioned, global warming. That's exactly what you'd expect from warming caused from a well-mixed greenhouse gas like CO2. If it was some other natural strange mechanism, you might expect a lot of warming in one location and cooling in another location, or something like that, where this spatial uniformity of the warming really points to well-mixed greenhouse gases. We're measuring the greenhouse effect enhancement from space, and basically there's just no satisfactory natural explanation. So when we look back at previous climate changes, like a lot of them, for example, the ice ages, are due to changes in Earth's orbital parameters, so like the tilt of the Earth. But those are changing much slower than what we're talking about, like over a century timescale or 2-century timescales. Those are more like 40,000 year timescales, and so we know those aren't changing at the pace that could cause the change that we're seeing. So basically, that eliminates all of the previous causes of climate change as well, is that they're mostly just too slow. And so that leaves basically one explanation, is the obvious explanation, is that humans are increasing greenhouse gas concentrations and the temperature is going up in line with that, from the first law of thermodynamics.
I'm really glad you mentioned the whole the measuring directly the spectrum, right, of uh,
Mhm.
the radio spectrum it's coming off of Earth, right? Is what we're measuring, right?
Yeah.
From
Yep.
satellites, and how you can measure that it's carbon dioxide that's uh, blocking light, right? That
Hmm.
and I love that because it's a direct measurement. You go out today and measure it, and then I saw an article that was mentioning that. I can't remember where I saw it, and I also saw that mention how we are also able to take the amount of carbon 14 in the carbon dioxide in the atmosphere, and you can measure that. Yes, humans are the ones that uh, cause that by using fossil fuels because it matches fossil fuel
Yeah.
carbon.
Exactly. Yeah. That fossil fuels have a different isotopic signature, and so
Yep.
we
Yep.
know that it's coming from fossil fuels and not from some. I mean, for one thing, we know that we're digging up fossil fuels and burning them and putting them in the atmosphere. So it would be a huge surprise if somehow, like, we're measuring something where it seems like it's coming from some other origin, right?
Yeah,
Yeah.
Um,
just the quantity of burning. If you wore goggles and you could see all the carbon dioxide off gassing from all this stuff, you'd be like, "Holy crap, we are definitely changing some stuff here." Um,
yeah, I mean that's a really good point. Like, just human perception of various things. If we could see carbon dioxide. Now, one of the reasons it's a greenhouse gas is that we can't see it, so it's invisible to sunlight,
Mm,
lets it in. Um, but if we could see it, that would probably leave a very different impression.
yeah. Yeah.
cool. And what do you have to say about the past mass extinctions on Earth? You know, in the fossil record, we actually know that quite a few of them were directly because of large large changes in the carbon cycle. Is that true?
Yeah, I mean, I think a lot of it, a lot of the previous five mass extinctions have a lot more to do with changes in chemistry than necessarily changes in temperature. But of course, you get extinctions when the environment changes very rapidly, because organisms are adapted to a certain environment and then it changes and then they're not able to adapt fast enough. And so it's not, it's not all that complicated in that sense.
And
So
we're
that,
definitely oh, sorry, DJ, but I was gonna say we're definitely changing it at a rate that that the planet has never experienced before, right?
Yeah, apart from perhaps asteroid impacts or comet impacts, we think that this rate of warming, especially if it were to persist at this rate, we're setting a new global temperature record, or at least over the past few hundred years, we're setting a new record every few years, and that rate of change is probably like 10 times faster than the rate, for example, coming out of the last ice age. So yeah, it's very difficult to adapt to for natural systems as well as human systems.
Cool.
so that actually kind of brings us to our next question. Is climate change dangerous to humanity and other organisms if we don't do anything?
It's certainly dangerous if we don't do anything. So there's enough, fossil fuels in the ground to completely melt Greenland and Antarctica, or the ice sheets on top of them. And so that represents like 60 meters of sea level rise. So 200 feet of sea level rise. So you're really talking about reshaping the coastlines in that type of situation. Now, it takes a really long time. It takes much
Mhm.
longer than people maybe think, especially if they watch kind of climate documentaries, because that gets left out. Those ice sheets took millions, tens of millions of years to build up. And so you don't melt them in decades or even centuries. So we're talking more like 1,000 years, 2,000 years to completely melt them anyway. So it's not something that just happens overnight, but it's something. I mean, 2,000 years. There were humans around 2,000 years ago, so it's not like that's some totally, some timescale that we totally can't comprehend. And then also, there's enough fossil fuels to raise the temperature enough so that like a lot of the land surface is basically uninhabitable to mammals or to humans. If you look at the way that they quantify this is with wet bulb temperature, which is just a measure of temperature that kind of takes into account how well organisms are able to kind of cool themselves down just through sweat and evaporation. And when you do that calculation, you see that a lot of the tropics becomes uninhabitable for mammals and humans if we were to really, double down and find all the coal and burn it and decide to go that route. So if we do nothing, then certainly it's we have the potential for a huge catastrophe and for all the worst type of things that you hear in terms of existential threat and everything like that. That is a ways away. So when we're looking at impacts right now, I would say that we can see very clear signals in heat waves increasing. We can see clear signals in cold spells decreasing, so not increasing, as you might hear.
Mm-hmm.
We see some signals in extreme precipitation. So as it gets warmer, the atmosphere can hold more water vapor. 7% per degree Celsius increased. And so there's more water available to cause kind of extreme precipitation events or flooding events. There's kind of mixed signals on wildfires, kind of mixed signals on tropical cyclones so far. There's a study recently on Hurricane Katrina, which gets brought up a lot in the context of climate change. And they found that the warming that had occurred by the time Katrina formed did not change the wind speed at all of Hurricane Katrina, but it made it essentially rain 8% more than it would have otherwise.
Oh.
So that's kind of the level that we're talking about so far with 1 degree Celsius warming. And then, so then there's concerns about agriculture, for example, that there's the more days that corn and wheat and soybeans spend over 30 degrees Celsius, you have kind of large drops in yield beyond that. And so people will do projections and find that we get, if without adaptation, you get large decreases in yield. Now, historically, that has not been the case because technology has way overwhelmed that temperature effect. So changes in irrigation and fertilization or fertilizer and things like that have outweighed any detrimental climate impact. So I would say right now, as far as humans are concerned, a lot of the negative impacts are kind of hidden in the noise. They're not necessarily as large as you might suspect if you're consuming a certain brand of climate media. But that doesn't mean that they can't get quite bad, because we're talking about extreme mitigation measures would be to meet the Paris 2-degree goal. And that's already twice as much warming as we've seen, right? So that would be like a very extreme mitigation scenario is we only get twice as much warming. And it'd be much more likely to see 3 times as much warming. And, it's possible to see 4 times as much warming by 2100. And then the world doesn't end in 2100. There's more time after that. So just because right now I would say a lot of the impacts are kind of in the noise, that doesn't mean that that doesn't discount all the other things I said previously about that there is the huge potential for catastrophe in the long term.
Cool. Well, not cool. That's kind of harrowing. Well, crap. If we don't get our act together, I mean, things could get bad. It's like, a car without airbags. Would you kind of what do you think about that way of saying it?
Yeah, I like that. I like you know, I think there's too much expectation on scientists that we should be able to know exactly what the impacts will be at what time, and when we can't do that, there's kind of this attitude of, well, come back when you like know all that stuff. And
That's
I
the way
do
science
like
works.
these analogies that are more like, that invoke risk, because that's really what we're talking about here, is that we don't know the future, especially when everything is changing. The climate is changing, but also society is changing and technology is changing, and you have populations changing, and all this stuff. So we can't have these quantitative predictions of, oh, this many people are going to die in this year or something like that. But you can think of it like risk, and like, why you would, would you drive without an airbag, or would you, choose not to get fire insurance, or analogies like this, I think are helpful ways to think about it.
Cool. So, can we fix the problem of climate change, and how dire is the situation?
Well, like I was just saying, with the impacts, the way they are now, I wouldn't say that it's dire now. And so if we were in some situation where we were already close to solving the problem, as in transitioning away from fossil fuels for our energy towards something else, then I would basically say, it wasn't that big of a deal. The problem is, what makes it dire is that we're so nowhere near close to solving the problem, and we have, a lot of headwinds facing us. One of those is population increases. So we're at, 6-7 billion people right now, but expected to plateau at around 11 billion. But
Hmm.
that's a lot of additional people, consuming more energy. And then we're expecting, the developing world to live much more like the developed world. So, one projection is there's a billion cars on Earth today, and it's going to be closer to 3 billion by 2050. So, tripling the level of cars on the planet, if those are all internal combustion engine cars, that's this huge headwind. And all of that additional CO2, just accumulates in the atmosphere and causes warming downstream. So those types of things, it's not just cars, it would be electrifying the developing world. It was China over the past decade. It will continue to be China, consuming more energy, but then India and then Africa. After that, you're just going to have this huge increase in energy consumption. And so, if that increase in energy consumption is with fossil fuels, then that's what makes the situation super dire, because then you're talking about kind of just baking in all of this additional warming that then is, irreversible on the timescales that we care about.
So that actually kind of brings up a interesting subject. Is a lot of people I see on the environmentalist left really seem to think, okay, if we all just kind of hunker down and use less energy, we'll be able to solve this with that. And I have always been very skeptical of that, especially if you want developing countries to develop and because that's one thing they need if they want to have prosperity and stop increasing in population and whatnot.
Yeah, definitely. I don't see how someone can appeal to the idea that you want to make the world habitable for your grandkids, but you don't want, the people in Africa to be brought out of poverty.
Hmm.
And so that is such a key part of this, is that we want the rest of humanity, the many billions of people who don't have electricity, to have electricity and to have a standard of living like we have. And so I don't think that's an option, is to say, oh, we'll just disallow that so that the earth doesn't get warmer. And so, yeah, I think that's a troubling um, kind of ideology on the environmental left, the kind of anti-human side of things that
Right.
would be, again, that would be like for population control or for, forced
Hmm.
degrowth or, no economic
Austerity.
growth.
Yeah,
Yeah.
like austerity. So, just so if we want to get this figured out, what needs to happen and when? Like, how can we fix this?
Yeah, so I think the right way to look at it is using the Kaya identity, which is a little bit academic, but if you'll humor me, there's these four terms. Two of them I was just talking about. So you multiply these things together, and you get how much CO2 emissions we have. So there's global population, how many people are on the planet. There's goods and services consumed per person. So that would be like the how wealthy we are part. That's the second term. The third term is the energy required to produce a given amount of goods and services. So we call that the energy intensity of GDP. So that would be like efficiency. So if you were to change light bulbs from incandescent to LED light bulbs or something, you're getting the same service for much less energy. And then the last term, this is what I would emphasize, is the CO2 emissions for a given amount of energy. So we don't want, I mean, we could hypothetically reduce CO2 emissions to zero by eliminating any of those. So if you eliminate human population, then you're going to eliminate CO2 emissions from fossil fuels. If you eliminate all the wealth, GDP per capita, you can eliminate emissions, CO2 emissions. Those two things we want to keep, or we're going to allow population to keep going up, and we want GDP to keep going up. The energy intensity of GDP, that is already coming down. So we use less energy. We're getting more efficient at producing goods and services. So that's good. That's coming down. That can come down faster by kind of imposing various efficiency measures. Yeah, there'd be a number of different policies that could do that. But really, the key thing is CO2 emissions for a given amount of energy. So that's changing the energy system from one that uses fossil fuels, coal, oil, and natural gas, to things that don't emit CO2. So nuclear is obviously one of those, hydroelectric, wind, solar, geothermal. Um, those would be the main ones, or fossil fuels where you're using carbon capture and storage, and you're not dumping the CO2 into the atmosphere.
So basically, separating carbon dioxide from our industrial base.
Yeah,
Cool.
exactly.
Yeah.
And the challenge is really, is really obvious when you think about that. CO2 just accumulates in the atmosphere, so emissions need to come down to zero in order for CO2 to stabilize and for temperature to stabilize. So it might sound good if you say, oh, emissions are coming down, and they are coming down in the United States. And they peaked in California in 2004, and they peaked in the United States in 2007, and they're coming down. But that's still, the faucet is still on. You're just tightening it up a little bit.
Hmm.
And so the water in the bathtub is still rising. And so the challenge is you have to get down to basically zero emissions.
Yeah. I think a big part of the, correct me if I'm wrong, the reduction in CO2 emissions, the carbon intensity of our energy, a lot of it has to do with our switch to natural gas. A big part of it, at least natural gas, like what, 60% or something like that.
Yeah, my understanding is it was like half the switch to natural gas and half wind
Okay.
and solar expansion.
Yeah.
So there has been a big wind and solar expansion, and that becomes more practical as storage gets cheaper. So storage has also come down. I mean, both wind and solar have come down in price dramatically, and storage has come down in price dramatically over the past 10 years. And so that's why you see most plans really emphasize wind, solar, and storage. Those are relatively intensive in terms of materials, and wind and solar take up a lot of land, so it's hardly like there are no drawbacks to that. But that
Mhm.
seems like that's is the mainstream type of plan that you see. And then I
Yeah.
would I would be on your side that nuclear should also be a part of that as well.
Okay.
Cool. We'll get that. We'll get to the idea of using
Yeah.
nuclear a little bit later, but we should
Yeah.
probably move on.
So I'll go ahead and bring up the next question here. So many people tend to take the issue with, quote, climate alarmists. Um, would you consider yourself one? And is such alarmism counterproductive or misguided?
I don't know. Do you think what I'm saying sounds alarmist? I mean, I think it just
Not at all.
totally depends. It
No,
I
depends
think
on
you've
your
answered that. Yeah.
yeah. It depends on your baseline though. You know, if you think that climate change is a Chinese hoax, then you might be alarmed by learning what I'm talking about. But on the other hand, you know, I encounter a lot of people on Twitter, and they'll direct message me a decent amount that are under the impression that like humanity is going to go extinct within their lifetimes. And so
right.
in that case, then no, I'm the opposite of an alarmist. I don't see any evidence for something like that at all. And so I do think that there is a problem with that type of alarmism, that they're learning that from somewhere. And I think that that eventually they'll become just disenchanted with science or with knowledge in general when that doesn't come to pass. So, you know, there's
Mhm.
things like I remember last year with there were Amazon um, fires, that was a big social media thing, that oh, the Amazon is on fire and it's the lungs of the earth and like we're gonna suffocate or something like that. And then when you look at it, it's like, oh well, actually this isn't even a, you know, a historically unprecedented fire season. One, two, it's mostly slash and burn. Like it's not wildfires, it's deforestation, which is also a problem, but that's a different thing than climate. And you know, three, that our oxygen supply is in no way in jeopardy from these types of fires. And so stuff like that, when that gets out there and it gets into people's heads as if scientists said that, and then oh, they never hear about it again, I think that really undermines, you know, trust in science and in news coverage of science and things like that. And so I would be very much against that type of alarmism, because it's wrong and counterproductive.
Right, and I'm worried. I think when people say, "Oh, you're just being an alarmist," it's just like, at what point am I not being an alarmist when you're just stating the damn problem? And it starts it gives cover, I think, to some, people that reject the idea that climate change is even happening. What what when do we? I guess this is all up to interpretation, but when does the alarm need to be like, "Hey guys, we need to do something serious." It's like there's an asteroid coming towards Earth. We need to deflect it. Like when do we when do we panic?
Yeah. I mean, I wish that we could all just dispassionately act rationally and make decisions based on the best, you know, interests of everything that we're weighing. And that's kind
Preach.
of, I guess, how I treat my classes and things. Is I don't really feel like as a climate scientist it's my job to motivate action or to inspire action. I think it's my job to inform, and then it's
Mhm.
up to other people to kind of do the motivational side. It's like if I heard from epidemiologists about the current pandemic, I don't want them to, you know, like if they think everyone should wear a mask, I don't want them to tell me you have to wear a mask or you'll vaporize and die in 2 minutes or something. You know, like actually want them
Mhm.
to just tell me what the facts are, like why you've come to this conclusion. And so I try to do that. I try to respect other people and their judgment of what's the best thing to do. But historically, it's true that hasn't worked. I mean, emissions have only gone up and up and up, and so, you know, other people have said, okay, well, I'm going to exaggerate on X, Y, Z, either subconsciously or consciously. I don't think that that is the job of a scientist to do, but maybe, you know, communicators and and activists feel like feel more justified doing that.
That's our job. Our job is to do that.
Yeah.
Yep.
So it's interesting you bring up. Sorry if I'm sidetracking here a little bit. You kind of paralleled with the pandemic and what the science community or what epidemiologists are saying or what they're saying about masks and stuff. And I think the message, there has been extremes on the messages, and I think it's caused some people to tune out to the news on some of those messages, even with such a thing that you'd think would be really apparent, like a pandemic where people are actively dying right now. People have already tuned out extremes and tuned out the news.
Yeah, I mean, I feel the same way. It's like you hear one thing one day and one thing another day. I mean, one of the reasons I think is that information is so decentralized, and we're getting it kind of from social media, and
Hmm.
so people are kind of living on different planets, and uh, I definitely see that as a problem for climate change as well.
You have written an article in Quillette magazine entitled Empiricism and Dogma: Why Left and Right Can't Agree on Climate Change. Could you briefly explain your take, and what would you say is the biggest political hurdle to produce effective mitigation strategies?
Yeah, I guess the point of that article was just that the kind of the narratives and themes and ideologies that go along with the solutions to climate change really align well um, with those that are already embedded in the kind of minds of people on the left. And so my only point there was just that it's not so much the dichotomy is that people on the left are driven by pure reason and logic, and people on the right are dogmatists. It's more that just the solutions to climate change are kind of inevitably collectivist and have to do with kind of world government, and these things just kind of align better with the politics of those on the left. And so I think, that's why we've seen the Democratic Party in the United States be much more on board with climate policy than the Republican Party. And we've seen with things like the Green New Deal that the Democratic Party finds this to be an issue that works very well with pre-existing kind of ideas as to how society should run. um, and so I don't necessarily have a, you know, quote unquote Republican solution, as long as, I guess these parties are always evolving, but like the way I'm thinking of it right now is kind of Republican being more like libertarian and anti-government. And this really is kind of a government problem. It really is, it's the type of thing that government was made for, where individuals acting in their own self-interest don't get you to the ultimate optimum solution. So I don't know if there's a way to fix that. I think kind of the whole window has moved so that now, there's a loud enough voice on the far left that's kind of calling for a socialist revolution to solve this, that now there's kind of room for people on the right to be like, okay, we're not going to do that. So how about we have a carbon tax, or we have this program that that encourages wind and solar and nuclear, or whatever. So it'll be interesting to see how that conversation evolves. I mean, historically, the Republican Party of the United States has basically done nothing, but I think now they'll be forced to come to the table with solutions.
Interesting.
Definitely. The let's not tell the last guest on our podcast what you said there. We had the libertarian uh, uh, presidential candidate actually on, so it was,
Yeah. Well, I mean, I would say it's great, if we can just say innovate away and the cheapest solution works, and there's something that beats fossil fuels, that's amazing, that's great,
mhm.
and that's the ideal situation. The problem is fossil fuels are really good at what they do, and they have this negative externality, they have this long-term negative side effect that just accumulates in the atmosphere, and it's delayed in time, and it hurts people decades and centuries into the future. And so that's the whole point of doing basic scientific research. We wouldn't have known about this if we hadn't invested in science. And it's the type of problem that government is basically exists to solve. And so long as fossil fuels are the cheapest, quote unquote cheapest, without pricing in the negative externality of having to clean up the mess in the future,
Exactly. Yeah.
then you need to do something like put a price on carbon to correct that market failure. And that's something that a libertarian should be on board with. It's
Yeah,
correcting a market failure.
and I
Yep.
and I tried to bring up the carbon fee and dividend, which is kind of the 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 big thing with economists on how to correct the market failure and the tragedy of the commons issue of uh, this carbon dioxide pollution, because polluting is it's violating other people, and you just can't do that. And it's the government's job to make sure you don't pollute.
Yeah.
Yeah. And that's totally mainstream, neoliberal economics too. That's in Thomas Sowell's basic economics book. He talks about that. And it's in, Greg Mankiw has like the main, economics 101 textbook. It's just, right there. This is what you do with pollution, and CO2 is a pollutant. And so I think that that should be something that, especially when the other side is saying we need, you know, in like government takeover of all industries and everything, that something like that, like a carbon price, would be more palatable.
Yeah. Yeah.
Got
And
it.
I definitely, as a person that does nuclear power, I find it a big problem of that like you mentioned, the negative externality of okay, so nuclear, they are required to control 100% of their waste, right? And or nearly 100% of their waste, and contain it and keep it from the atmosphere, biosphere. And then all these other industries just get to toss it up into the into the air,
Right,
uh
exactly. Yeah.
and yeah, uh I think that negative externality really does need to be taken into account too, in a carbon tax or something. So let me get to our next question. What things do the left and right do wrong when it comes to climate change? And you did talk about that a little bit, but
For sure.
Yeah, I would just say, kind of reiterate that I think the right historically has just denied it, and that's not a sustainable position going forward. And yeah, the far left, at least, what I see on some extreme voices on Twitter, is definitely doing things wrong, in my opinion, of going too far down the kind of anti-humanist, um,
right, right.
society route, essentially, that we need to completely throw out all of society because of climate change. And I think that's unhelpful politically, and it's also not something that I would advocate for.
Yeah,
It
no,
also drives division. Yeah.
Yeah.
I mean, I would say, yeah, I've noticed on the left, I'd say the biggest problem with the left is they just aren't looking at the pragmatic solutions. They're against gas, which gas for it's carbon dioxide, but at least it's less as much than coal, and they're the traditional like leftist kind of hippie folks, were got scared of nuclear power uh during the Cold War era, and the few accidents scared people, which was understandable. But we basically gave up on that technology. And I think that there's like this cult out there that says we need to only do the type of solutions that nature would have intended, like wind and solar and hydro. Like we need to just use the natural forces. And that's that's not how that's just not how society is gonna flourish. We
We used to live
we
that
we
way.
used to live that way, exactly.
Yeah.
So we're wondering what you think about that.
Yeah. I mean, I think that's interesting because it does seem like the wind, getting energy from the wind and sun, kind of makes you feel good from a like pantheistic perspective. But on the other side, it is true that they take up a lot of land. There's a lot of environmental issues with those as well. And when you're adding in the need for storage, you need to mine a lot of minerals for that. So I would definitely say, I mean, everyone, all the plans I see are very gung ho on wind and solar, and I think that that's doable with to a given level of penetration. So not 100% wind and solar due to their intermittency, but to some reasonable, penetration level, they seem to be good. But then, yeah, you do need that baseload power as well, unless there's some pretty big advances with storage, whether that's pumped hydro or whatever. And so that would be gas with carbon capture and storage or nuclear.
Yeah, we the left, and I think they're slowly getting to understand because younger kids are more okay with it. That you know, leaving nuclear off the table is really dumb.
And do
But
you
we'll
think
get
that
into
is
that.
a relic of the Cold War?
It's a mixture of things. It's just, uh, again, we have a more nuclear-based question up ahead, but, people scared of the Cold War, they associated nuclear power with nuclear bombs. They saw some accidents. People there was a lot of, like, mythology on, like, how bad radiation can get, you know, like, you know, s stuff like that, and just an anti-human Malthusian type of ecology where people were a lot of environmentalists, and there's like Sierra Club David Brower uh, said something like unlimited energy for humanity would be like the end of nature because we would just go bananas, and
Hmm.
which
Yeah.
hasn't really happened. So DJ, you want to say anything about that?
Oh yeah, like it's interesting you bring up Sierra Club because they used to be. Well, we are really getting into the next question here now, aren't we? We really used to be into nuclear power. Starting out, I don't know if you knew that, Patrick, but then you might know better than me, Phil. They eventually switched because they thought it would be an issue when it comes to population in California. It would bring more people and
Yep,
ruin the Californian landscape. Um, yeah.
for sure.
Well, I mean, something that has really proven that line of thinking wrong is the idea that when people become more affluent, they don't have more kids, right?
Exactly.
Yep.
So if that would totally throw all of this out the window. I mean, we're
It
super
does.
lucky that's the case, right? That as
Hmm.
we become more affluent, we're basically at replacement level or less, and it's the poor developing countries that's where all of the increase in population is centered. Um, but that's great that we kind of lucked into into that situation, because otherwise it would be the case. We can't just expand population forever.
Yeah.
Right.
I think
Cool.
that's kind of an outdated view too. That I hope is starting to that view is becoming less popular because I do find it with people who are more traditional, environmental, like hippie type people.
Yeah. It's interesting. I've actually heard in some Marxist circles, going all the way the other direction of markets, free markets, that they call it eco-fascism when people are just like, "Oh, you need to have less kids." So I think there is that type of thinking is kind of seen as foul, and I think that that's a good thing. But I think we should uh, move to the next question
Sure.
just for time. So now we're going to get to, the nuclear power part of this because we are a nuclear power organization. But what are your views on nuclear power as a major solutions to the emissions problem? Do you think that that solution would be the most bipartisan?
I am not sure about bipartisanship, but I definitely think that it deserves to be in the mix just with everything else. I'm kind of a all of the above type of person when it comes to the energy technologies that would replace fossil fuels. I mean, that's actually why I particularly like the pricing the negative externality of carbon dioxide emissions, is that it lets whatever the cheapest, most efficient solution win out. And so I would be all for nuclear if that's what wins out. I mean, we've seen countries scale that up very quickly. We've seen France do that in a matter of 10, 15, 20 years.
Yep.
And so it's something that we know can be done. That's not something we've seen done with wind and solar yet. Um, the wind and solar advocates would say that we can deploy at that level. But yeah, I would say let the technologies compete. and see who wins. I mean, I know in your mission statement you talk about nuclear being safe, cheap, plentiful, clean, and efficient. So it gets challenged on safety and cheapness the most, I think. I think
Right.
safety, empirically, historically, it's very safe. And, I know the stats about it being, killing far less people than basically every other technology, especially coal, because of all of the, long issues with coal. But even, people falling off roofs of, installing solar panels, it's less than that. But
Mhm.
I would be interested in what would say about the proliferation issue, and just because there hasn't maybe been a meltdown that caused huge number of deaths, does that mean that there won't be one in the future? So I'd be interested in your take on that.
I
Yeah.
Yep. Oh, sorry. I'll let you talk about the meltdown part, but I was going to say about the cost. It just depends where you are. Like right now, the cost to build in the United States and parts of Europe have just ballooned out of control. But you look at South Korea and China and Russia, and I think I don't know how the price range of India. Oh, Ontario. Uh, they've brought nuclear, you know, way scaled it way up, and once they got it built, they have some of the most affordable energy prices in the world. It's well, not in the world, but like similar to that of coal or gas. So, but
Mhm.
it's the upfront cost that people would say like, oh, that's why we shouldn't do it. But the innovators can bring that cost down. But go ahead. What were you going to say, DJ?
Yeah, yeah. So you mentioned so nuclear safety. It's very interesting because that is there's so many misconceptions. If you would to say someone had a meltdown, you would think it's the end of the world type of thing, but that's not true at all. Actually, if you think about worst case scenario for a Western style reactor. So I'm discounting Chernobyl here. They were a interesting. They are not a Western style reactor, and that type of reactor, as it was built in that day, doesn't even exist anymore. Even the ones that are running today are have been completely modified and changed. But think of the worst case scenario, which is Fukushima. It's a triple meltdown, and even with that triple meltdown, with a large amount of nuclides released, there will be no um, discernible effects. So you can't even measure the effects when it comes to the radiation um, dose received by the by people, or
Mhm.
even the environment too. So it's interesting. We treat it as being such a uh, terrible thing, but a lot of it really has to do with that misconception of radiation and what it does to people. And I really hope to actually, in my career as a health physicist, really make that a point in my career to communicate to people about the actual risks when it comes to radiation, but they are way lower than what people seem to think. Even in a worst case scenario, you could move people back right now to the exclusion zone, and you likely would not see any health effects to the people.
Were
Yeah,
they storing waste on site there?
yep. And that waste moved from what I've heard, 4 inches from where it was sitting because of
Okay.
the tsunami, and was not impacted.
Oh yeah,
Um,
the fear mongering of the waste is oh my gosh. If you actually learn, like I tell people, if you learn about the waste and how little of it there is and how like easily managed it is, I'm like, you'll almost realize you were lied to about it. uh,
Yeah. So
it's
what I hear
crazy.
mostly is just the time scale that concerns people.
You know,
Is Do you think that's right? It's just that it's not as dangerous as.
um, DJ might know more about this, but a lot of the fresh out of the reactor fission products decay to background like within a few hundred years. The 1,000-year timeline is for like plutonium and uranium, but we can actually use that again in new reactors. But
yeah, yeah. Um, and then to add to the you were mentioning the waste part. I should mention that there was also the fuel. I can't think, spent fuel pool,
Mhm.
that they were concerned about. People thought, oh shoot, this reactor over here just had a hydrogen explosion, like, but there was no fuel in the reactor. Shoot, maybe the spent fuel pool um, ran out of water, and that's where the hydrogen came from and caused the explosion. But then it turned out that actually was not true. Once everything finally settled down and they finally looked at it, they go, it is warmer. The level has fallen a little bit, but it was just fine actually. But I hope that answered your
Gotcha.
question.
Yeah,
I
yeah.
didn't
I
know
mean, those are the things, right? Like it's storage, it's expense, and so I think sometimes it gets said that it's not actually renewable. Is that so? Is that just the case with uranium 235, but not with other fuels? Or
Well, the idea of renewable, I think, is kind of a fallacy to begin with. But they say, oh, it's not renewable because it requires a fuel source. But we are never going to run out of uranium, the same way we'll
Mhm.
never run out of fossil fuels. And in fact, we have enough eh, potential isotopes that we can, breed in reactors to fuel humanity for like like million years, even
Basically
if
until the
the
sun goes out.
sun goes
Um,
out.
and uranium 235, sure. Like, so if you're using just uranium 235, that is the more rare of them. But we still have a lot of that actually. People like to focus on the uh, what's it called? Phil was kind of alluding this too, but the known resources that we have.
Mhm.
But those known resources are only they've been this. We basically said we've had this many years of uranium 235 left over, and then that was like years ago, like decades ago, and we still have that same amount, like,
Right.
because
It's like the proven reserves of oil keep going up, and yeah.
exactly, exactly.
And if we like a lot of our spent fuel it has a lot of the fuel left. Basically, the fuel rods just wear out. Um, but if you can recycle that, I mean, that's already we never have to mine for it again. You can get it
Yep.
from seawater. It's crazy. Essentially, it's a fuel that is not worth anything. It's basically just a piece of matter you use to turn into energy, and it's so much of it. So when they say nuclear is not renewable, I would argue, and a lot of us nuclear people argue, it is the most renewable because of you get so much bang for your buck for little like material inputs when you need a lot of solar panels and a lot of wind turbines to make that whole thing work. Uh,
Yeah.
and it has just a little less footprint on the landscape. And I guess the reason why a lot of people have come over to nuclear is they started to really like look at some data. Okay, what sources of power don't emit carbon dioxide? Oh, nuclear is there. What are the safety records? Oh, nuclear is actually one of the safest. They look at in terms of like the cost once they're built. Oh, looks like nuclear is actually not that bad once it's built. You just look at various different metrics, and you're just like, holy crap, maybe there's something to this, and then you just kind
Mhm.
of focus on it, and that's why I'm an obsessive person about it. But I genuinely think the data shows that nuclear holds the most promise to stop this climate thing. And I like to tell people, oh, if we did not have invent nuclear fission, we'd be in a lot of trouble. So that's
Mhm.
kind of how I see it.
Well, I
Yeah.
guess it's up to you to make it bipartisan then.
We are, and it's
You're
actually
trying.
there's
Yeah.
actually there's actually a lot of bipartisan bills passed about nuclear, which is interesting. And the recent Democratic climate response included next generation nuclear, which is I wish it would be a cornerstone, but at least they mentioned it,
To
and so it's
start.
not it's a start.
Yeah. It'll be interesting to see, because I think we're kind of running under the assumption that you need bipartisan support to get something done. But that's not necessarily been the strategy where, like the alternative strategy is to kind of wrap climate policy in with a bunch of other things that you think do have support on your side and then get it passed, that way. And so I wish we were, much less polarized, where it was always the strategy
Mhm.
was to try to get, some portion of the other side. But I have noticed that, the alternative way of doing it is to just say, no, try to win your election as much as possible. And then if you're a Democrat, then get your climate bill passed with 0 Republican votes, because they're not going to vote for it anyway, no matter what. Um, and so
That's
that would be,
unfortunate.
yeah, yeah.
Yeah.
Because then I think it's just a pendulum. Is then the next administration comes in and undoes everything that was just done.
Yep. Yep. I think we're definitely seeing that kind of thing today. Yeah.
Yeah.
Well,
Yeah.
when it comes, we should probably
Yeah.
move on to the next question here.
Yeah. So, what other evidence-based strategies would you suggest to bridge the divide and actually lower emissions quickly and affordably?
Well, yeah, just what we've been talking about. So we have to switch from coal oil, and gas to other sources that don't emit greenhouse gases. So nuclear, wind, solar, hydro, geothermal. And then, that can be helped with a carbon price. And then you have to, electrify more parts of the economy. If, I guess with nuclear, you can do a lot of the kind of cement and steel manufacturing
Mhm.
directly with nuclear power. And so that helps a lot with decarbonizing industry. But for example, like switching from oil, the mainstream idea anyway, is that you basically electrify all the cars, you have electric vehicles, and so that's going to increase the demand from electricity, and then you have the electricity system be, nuclear or wind and solar and hydro.
Hmm.
And then you do have to get all the way to zero. You have to, get rid of the methane emissions from agriculture. You have to get rid of the nitrous oxide emissions as well. That's I feel like there's too much arguing right now about that last 20% of
Yeah.
emissions. And
Yeah.
first, like we'll deal with that when we get there and see what technology is available when we get there. And for now, we can really hopefully start just decarbonizing the electricity sector first, because that seems like that's what can be done first. I mean, one thing that should be bipartisan is that we could end all fossil fuel subsidies, which
Right.
is kind of easier said than done because they're hidden in a lot of different policies. But that should be something that the right and the left should agree on. That if fossil fuels are really better, they should be able to win just on their merits and not be subsidized.
Right.
So that helps with emissions right there.
Yeah, and you mentioned carbon pricing. I think that is definitely a way to go. I mean, it seems like that's a little bit more straightforward than like cap and trade. Cap and trade kind of can cause some other like kind of cheating, basically. Um, but
Hmm.
like carbon pricing, and the conservatives that are concerned about climate change and want to do something about it, they're they rally behind it. If anybody's heard of Citizens Climate Lobby, they push the idea of carbon fee and dividend. It's supported by scientists, climate scientists, and stuff. So I think that would be pretty. That's a pretty good solution.
Yeah. One thing that is being really advertised right now with wind and solar and, you know, kind of modernizing the electricity grid so that you have a larger transmission area so that you can take advantage of anti-correlations of wind and sun. One thing that's advertised with that is that it creates a lot of jobs. Normally we don't actually want to create jobs for the same thing,
Hmm.
right?
Hmm.
You don't want more jobs per joule of energy, because that's
Right.
synonymous with it being more expensive.
Exactly. Yeah.
Like we wouldn't say, oh, let's ban tractors so that we can have more jobs in
Right.
agriculture. But right now, with huge unemployment, that does seem like both an economic and political win, because you have all these idle resources and people unemployed. Um, and so, what is the job situation with nuclear? If we were to say try to do what France did, I mean, is that a job creator, or I mean, with the caveat that eventually you don't you don't really want more jobs in the energy sector.
That is a great question, and I there is some interesting, if you talk to some of the circles when it comes to like the pro nuclear circles, uh, if if you look at like NEI, they'll might mention like, oh, they're a big job creator, but then if you talk to some of us, we're like, well, you don't, like you said, you don't want to um, make more jobs per unit of energy. I know locally it is a huge deal. Like if you go to some of these towns that have nuclear plants um, near them, when the nuclear plant closes, they're done for. The
Hmm.
towns really suffer. So I would say at a very local level, it is a huge economic um, thing. It's not just jobs. There's other huge benefits. Great emergency management, good infrastructure, and whatnot that comes with that.
Right, like, I was gonna say fossil fuels are pretty, uh, like, once you have these machines running, it doesn't really take that many people to operate it, and the same thing is with nuclear, but it requires a little bit more people, but it would not
Mhm.
require the same amount of, you know, labor costs as, like, massive wind and solar, operations because it's smaller, so it's a really actually one of the better ways to, keep like, it's a good it pi it's like nuclear, I've heard, is like from one of my friends, but I mean, we talk about this stuff all the time. It's one of the good jobs that are well-paying and actually, like, enrich local, uh, areas and doesn't cause prices to skyrocket. So, I think it would be a good jobs program, and especially just building these things, it's gonna require quite a you know, bit of labor, but once it's built, it doesn't require continuous, hard labor. So it's one of the better, industries you could elevate during a, recession or something. So
And you have Homer Simpson as the role model.
Homer Simpson as the role model. Yeah,
Jeez.
he's chief safety inspector. If anything, Homer Simpson deserves a Nobel Peace Prize. I'm just kidding.
Right.
But
So what's interesting is that I know that the jobs for nuclear when you're building them, like so this would be an interesting thing. Like if they decided right now, let's pandemic's going on, we need to create a bunch of jobs. If they were to, let's say, start building a bunch of nuclear plants, that would provide temporarily a large amount of jobs because when you're building it, that's a lot of labor right there. You increase um, the population of the local towns quite a bit during the building process, like Phil mentioned. But then when you're running them, they do take, I want to say, in the 800 to 1,000 people range, which is actually dramatically more than what they were pre 9/11 and pre what's it called, 3 Mile Island.
Hmm.
When they added more jobs, especially pre 9/11, they added a lot more. They added a lot of security jobs after 9/11 happened. Which, if you talk to some people, they might tell you like too many security jobs. The amount of security jobs that are uh, on site, I want to say there's more security personnel than any other personnel on site. So
well, we've been talking for a while now, and we're kind of reaching the end of our time. I could talk forever, uh, but I was wondering, do you have any final thoughts?
Yeah, I mean, I would just say that it really is the case that what we do right now has very um, large downstream consequences. And there's just this situation where it takes a while for the science to penetrate into the general mind of the public, and then it takes longer for that to go into policy, and then there's these physical delays of once you build the next coal plant, which of course we're still building new coal plants all over the world, those are going to be in existence for 30 or 40 years potentially, and have CO2 go into the atmosphere for 30 or 40 years. And then that stays in the atmosphere for a long time. And there's this inertia with the ice sheets that then it, melts the ice sheets over long periods of time. And so I would just emphasize that that's where kind of the urgency comes from, is that all of the inertia in the system, both sociologically and scientifically and politically and then geophysically, makes it so that what we're doing now has consequences for thousands of years. And that's what makes the situation urgent, even though, I believe what I said about a lot of the current negative impacts being kind of exaggerated.
Great.
Got
Yeah.
it.
So yeah, thanks so much for joining us. I really hope that we can maybe in the future have some more conversation. I really enjoy talking back and forth with you, talking some nuclear and learning more about climate change. I hope that we can do this more in the future, even if we're not recording a podcast. But
Yeah, for
it,
sure.
yeah, it's definitely been very enlightening.
For
Yeah,
sure.
in lockdown, it's always great to talk to talk to people with similar interests.
Great
100%.
time to get back into podcasting, for
Yeah.
sure. I feel really inspired and hopeful about the future after this, and we are honored to have you on. And where can listeners go to learn more about you and your work?
I would say Twitter is probably the best place. So that's just Patrick T Brown 31 is my Twitter handle.
That sounds good, and we will hopefully talk later.
All right, great.
That's about it for this episode of Climate Fix. Dr. Brown is chock full of good information. It is good to know what experts in the field have to say. Climate mitigation is quite a complicated subject with many societal implications, and there are big differences in opinion on what humanity should do to approach this large challenge.
Absolutely. We know for certain that climate change is real, man made, and a threat to our current way of life. The way to solve it is to stop emitting greenhouse gases. How we do that is indeed the $1 million question. Hopefully, the views shared by Patrick provide listeners with a different perspective of the issue and what to do about it that deviates a little bit from the mainstream media.
Climate scientists that are not panicked by climate trends, but see it as urgent, do exist. And yes, many climate scientists do see nuclear power as a major part of limiting the greenhouse effect. Politically, both sides of the aisle have major strengths and weaknesses in confronting the scientific facts and how to respond. Hopefully, this episode helps bridge the political divide on an issue that affects everyone.
For sure, these days it is hard to make sense of anything with such division. But if we think hard about solutions, we can solve anything if we try. It is possible to understand the science of climate change, want to solve the emissions issue, and also not want to disrupt our current standard of living. More people are in the middle than we think. The future is bright. You can follow us on Facebook, Twitter, Instagram, Tumblr, and YouTube. Lastly, we really want your feedback. Let us know your thoughts, questions, and concerns. We have a message form on our website under the About section, or you can email us directly at main@Americans for Nuclear Energy, all one word, .org. Again, that's main@americansfornuclearenergy.org.
If you like what you heard and want more content, you can support us and our mission online at www.americansfornuclearenergy, all one word, .org. Again, that's www.americansfornuclearenergy.org. We have a link to donate with PayPal under the Mobilize page. You can also purchase some A&E swag under our store page. This will really help us pay for the little things, especially online service fees to keep our organization running. We are a group of almost 10 volunteers at the moment, and we could use some monetary support.
Thanks for tuning into this episode. This is Phil Ord
And DJ Leclerc.
of A&E's Climate Fix podcast. We'll see you next time.